Hi, my name is Jordan Freeman, and this is my assignment 6 for CS225 Spatial Computing. And for assignment 6, I'll be parsing data and generating heat maps using GeoPandas, Pandas, and PySpark. So let's say we have a data set that looks like this. This data set shows the influenza-like likeness by region in California from the years 2001 all the way up to 2020. And it stores all this data weekly. So the question becomes, how do I map out this data? Well, first, you need something called a shapefile. A shapefile is a non-topological format for storing geometric data. When plotting it out, it looks something akin to what we see in the bottom here. And when we look at the data itself, it looks something like this, which we'll get more into a bit later. So the question becomes, how do we combine a shapefile with the data? And this is where GeoPandas comes in. GeoPandas is an extension of the Pandas library in Python. It makes working with geospatial data easier. So from here, let's go over to Jupyter Notebook and start working this stuff out. So these are the libraries that I'll be working with here. So I'll be using PySpark, GeoPandas, and Pandas. The reason I'm using PySpark and Pandas, as opposed to one or the other, is that both have their pros and cons when it comes to reading datas and other and showing data, as well as how other things like Matplotlib interact with these things. This is just from experience from the project. And this right here is me creating some directories in my file explorer. So here's basically what it looks like. This is where we're going to put all our heat maps at. And this is for storing all of our fluid data once we separate everything out. So to understand why we're separating it out, let's first showcase the data. So as I said earlier, this file stores influenza-like likeness, as you see here, by region. But in order to actually merge this CSV file with the shapefile, in order to make the heat map, we need to merge both files using a common column, essentially a spatial join. But when we look at both files, neither of them share any common regions, common columns, I should say. The closest we have is this region column here. Now, luckily for us, I have access. I know where I got my data set from, and they have this data dictionary section here. Now, as you see here in the data dictionary, what each county, that's in each region. So, for example, in the lower and southern region, that includes Imperial, Orange, Riverside, San Bernardino, and San Diego County. And if we head over here to the US Census and scroll down, we can get to here where it says county subdivisions. And when we click on California, we get this. And this stuff right here, this is the county NS number, which lines up exactly with this. So in order to merge these two together, you first need to process this CSV file and rewrite this region column to be the county NS here. And that's what I do here. So to go over what's going on in this code, this is in my dictionary. And I'm essentially going row by row in the CSV file. Then I'm reading in using pandas. And it's reading each column, each row value in the region column and replacing it with these arrays. So now that our data is generated, we can see our region column now looks more like the shapefile. But we're not ready to merge just yet. As you can see here in the season and date codes, that we're only seeing the first 20 rows, first top 20, but this entire CSV file holds weekly data all the way up to 2020. So we can't just merge the files together because there's going to be a lot of repeats with the regions. So we first need to separate each column, we need to separate this file by dates, by weeks, which is what this code does here. So first, I read this in using Spark, and then I select all the county codes, and then using Spark's filtering, I remove. I basically go region by region, or sorry, county by county, and gather everything up for that particular date. No, I'm sorry. I'm not going county by county. I'm going week by week here. You see the date code. The way this date code works is that this is um, year 2021, week 40. So it reads that date code and it stores all of those. And then it filters, and then this here, we're using Spark's filtering function to filter out just that date, that week. And then we're putting that into an output file. Now, this whole process, all of these mini CSV files are being stored here. You see it being generated in real time. But I'm not going to let this run because that would take a very long time. And I have already essentially gotten everything. I run this earlier so I can have all this data already set up. So all I'm going to do is copy on over. So now that we have now that everything's properly separated, as you can see with this example, we can now begin generating our heat maps. So first, I use GeoPandas to read the shape file. And then I go CSV file by CSV file. And the first thing I do is that I find the minimum infection rate for that week and the maximum infection rate. This is going to be useful for color coding a heat map. And then once I do that, I select my columns for merging, and I use GeoPanda's merge function to combine both files together. And then using matplotlib, I generate my heat map. And then I save everything into my maps folder here. So if I let this run, we're going to see heat maps for every week. But just like the flew by dates folder, that would take a very long time to get through everything. It's like it'll be over 1,000 weeks. So luckily I already ran this earlier and we can see all of our heat maps. So let's look at that. So in this heat map, you read this, is that this bar represents the colors, and at the bottom, this value here is the minimum amount of people who have gotten influenza that week, and the maximum value here is the maximum amount of people who got infected that week, and it splits this off by region. So if I look at this map here, the Bay Area got 25 people with influenza, and these counties here, I think that's the northern southern, or the upper southern, and central California, both had 0 as the lowest. And we can see this for every single week from 2021 all the way up to 2020, as we can see here. And with that, I thank you for listening and have a good day.